Oh, this is Algebra 2, Unit 6. We are going to be looking at exponential functions. I think you guys are going to love these. These are really awesome functions, and they really have a lot to do with real life. Now, in the HK format, this is how they look. Get this in your notes. Right now in this lesson, we're going to look at what happens with this b value. So we won't have an a value or an h or k. We're only going to look at the b to the x. We have two that we refer to as parent functions. It's just simply so that we have some kind of number to come back to and talk about. That is the parent growth function. We usually talk about it being 2 to the x. And the decay function, 1/2 to the x. Now I want to look at what happens here. Let's plug in some values and just get these graphs kind of formed. So if we have a -2, a -1, a 0, 1, and 2. So what's happening here, we put 2 to the -2nd. If you remember exponents, the negative needs to go on the other side of the fraction, the negative exponent item, so that would become a 1/2 squared, which would be a 1/4. The -1 would be 2 to the -1st, which would equal 1/2. 2 to the 0th, anything to the 0th power equals 1. 1, 2 to the 1st would be 2. And 2, 2 to the 2nd would be 4. So if you look at this, now this is the cool thing, is exponential growth. Look at the pattern here. We go 1/4, 1/2, 1, 2, 4. If we were to write that as a sequence, do you see what's happening? 1/4, 1/2, 1, 2, 4. What would be my next number? 8. Yes, it means that we're multiplying each previous amount by that growth factor. That's why we can see these so often in life, is when something starts doubling. Talk to Mr. G or one of another scientist that you know, and when you're studying bacteria and they start populating, usually it's almost always a exponential growth factor of how fast they're populating. You can actually predict how many bacteria or how many cells you're going to have in a certain amount of time by looking at how quickly they're multiplying. Okay, next one, the decay. This is considered the parent function for decay exponential function. Let me show you what happens here. If we plug in a -2, that would become 1 to the -2nd over 2 to the -2nd. It means we need to flip them both. It ends up being 2 to the 2nd over 1 to the 2nd. 1 squared is 1. 2 squared is 4, so we end up with 4. -1, we would end up with 2. 0, anything to the 0th power is 1. And 1, 1/2 to the 1 would be 1/2. And 2, 1/2 squared would be 1/4. Do you already see the pattern? Isn't this cool? So 4, we cut it in half, we get 2. 2, we cut it in half, we get 1. 1, we cut in half, we get half. A half, we cut in half, we get... Ha-ha! So our next one would be an 8. And that's how decay works. Now, interestingly enough, we have seen in medicine that we can study the decay rate of, or the decay levels of vitamin D in your body, and it follows just almost exactly like this at the same time that the potential for a cancer to form goes on a growth rate. So it's pretty awesome, guys, to be able to study those things. You'll be seeing them in class. Okay, so now let's just look at these on the graph. Interesting thing here that happens. They both cross at 1. And I'll be honest, I use that as my vertex point in my mind. When I'm graphing anything growth factor or a decay factor without an A value up here, I know it's going to cross at 1, so I start right there and then I just double or I just cut in half, and that just kind of gets me going. And I don't even have to plug in numbers to figure it out, I just look at my factor. There are some things that will change it from being 1 when we come back to this formula and we start plugging numbers in here, so you'll have to watch for that. Okay, but looking at the parent functions, we need to go back to Algebra 2.1 just slightly. When x increases without restriction this direction, what's happening to the y? The y is going to infinity. When x is going towards negative infinity, this direction, what's happening to the y? It's getting closer and closer to 0. Question for you, will it ever cross 0? Think about how you're cutting in half or how you're building it up. Will it ever hit 0? Can an exponential function ever hit that 0? And be able to explain why in class tomorrow. Okay, the next thing on the decay, when it approaches positive infinity going that way, that's when it's approaching the 0. And when it's going this way towards negative infinity, that's when it approaches positive infinity on the y. So I should be able to give you these parameters and you tell me whether it's growth or decay. Let's look at the domain for both of them. They go forever and ever that direction. So the domain would be real numbers. The range, neither one of them hit the 0. And so we can't do the bracket. The bracket would mean equal to 0, so it has to be a parenthesis that takes, that goes around the 0 to show that it won't touch the 0. And then infinity. It doesn't matter that it's infinity over here or infinity over here. This is my range, 0 to infinity. Okay. The other thing I want you to look at, how is this graph related to that graph? Specifically, think about your y-axis. Are they exact reflections of each other over the y-axis? And be aware of that when you have a growth factor and a decay factor with the same values in there, what they might actually be doing. Okay? Last thing I want you to do, I want you to go over to open up this window, if you didn't already have it open, to desmos.com/calculator. And I want you not to plug in any values here yet, but just to play with this b a little bit. Plug in y equals 2 to the x, and then switch the 2 to a different value, and see what's happening, and see if you could start to predict how to put those in there. Okay? I would ask that you draw at least 3 graphs of different values for b that are greater than 1, and then 3 graphs of values of b less than 1 but greater than 0. We don't want to go into the negative. We're not dealing with that. So between 0 and 1. And then I'd like you to draw with a 1 and be able to explain why with a 1 it does what it does. And then maybe make 3 predictions, then plug in those values into Desmos and see if you get those right. Okay, you get over to Desmos, work on that. Thanks.